Hi guys, I've been trying to make this video for the last half hour, but the cats have decided to wake up and sit all over my stuff. I'll have to show you pictures of that later. But we are going to go ahead and take a little bit of notes, and then I'm going to walk you through the next 6 problems. What I'm going to do is I'm going to set up the problems for you, and then you'll, of course, do the work and have your answers, and then type it into the Google Doc that's attached to the assignment so I can correct it. Hopefully this will take less time because I'm walking you through it. What I noticed is that the problems that I gave you before were a little bit harder, and it took me a really long time to give feedback. In fact, I'm still giving feedback to about half of the class still. So I'm thinking for those problems that I posted previously, I can do a video and that will be more helpful to try to streamline the process. Again, this is new for me, new for you, so we're making it up as we go along. Okay, so today I'm going to introduce you to something called the percent proportion, and it will help you a little bit solve some problems. And I've already talked a little bit about it, but I want to have it here in our work. So the percent proportion is, well, I'm going to set up a definition first. Proportion. And a proportion basically is just two equivalent ratios. And remember, ratios are like fractions, so the way we look at them is two things with an equal sign. So with a percent, we know that it is an amount out of 100. So the way we're going to look at a percent proportion is going to be a part over a whole equals a percent out of 100. And we think about it in terms of what we do to this, we have to do to this, or what we do to that, we have to do to that. Remember, what we do to one, we do to the other, in that sense. And we've been doing that this whole chapter, just kind of in a different way. So we're going to use the percent proportion in these next couple problems to try and help us solve. I have the problems written on a iPad, on my iPad, so we're going to look at them while we're reading. And then, so you don't have to write them down, so you'll see, we'll just go ahead and read them 3 times on here. All right. Okay. Action movies make up 85% of Devin's movie collection. If he has 20 movies, how many action movies are in Devin's collection? Explain. So we're going to read it again. We're going to look for quantities. Action movies make up 85%. 85% is a quantity. Movie collection is also a quantity. It's one movie collection. He has 20 movies, so that's how many movies are in his movie collection. So we can kind of put that with what we just said. A movie collection worth 20 movies. The question is, how many action movies are in his collection? So I'm going to take what I know and I'm going to try to set up a proportion. And what I'm looking for right now is a part. Because if we know the whole movie collection is 20 movies, we're looking for a number that is a part of that movie collection. So I'm going to head and move this for now, and I'm going to set up my work. The problem said 85%, which is written like 85 over 100. 100 is the whole, 85 is the part, 85%, 85 out of 100. And I'm going to make that equal to Devin's movie collection. He has 20 movies total, so that's the whole. The whole in his movie collection is 20 movies. The question is, how many are action? So, I got to think about this. What do I do to 85 to get the action? What do I do to 100 to get 20? I know that 100 is bigger than 20, so I'm going to go ahead and do division instead of multiplication. Remember, every time we are thinking in pre-algebra, we're thinking about relationships with multiplication and division, not addition and subtraction. So I'm going to take the 100, divide it by 20. I'm going to get 5. So 100 divided by 5 is 20. Now I'm going to do the same to the top. And I'm going to do 85 divided by 5. And that will give you how many action movies. Remember, I'm not giving you answers. You're going to type in those answers into the document once you're done. All right, let's look up number 2. Number 2, the drama club held a car wash on Saturday and Sunday. They washed a total of 60 cars. If they washed 40% of the cars on Sunday, how many cars did they wash on Sunday? So let's read it again. Let's look for quantities. The drama club held a car wash on Saturday and Sunday. Great. There's nothing really important in that part. They washed a total of 60 cars. That's important. Our total is 60 cars. That's our whole. If they wash 40%, 40% is a quantity, 40 over 100. If they washed 40% of the cars on Sunday, how many cars did they wash on Sunday? So I'm going to set up my percent proportion. And it's going to be 40%, which is 40 over 100. And we're looking for how many cars. So part of the cars on Sunday. Out of the 60 cars, both Saturday and Sunday. So, again, what do I do to 100 to get 60? What do I do to 40 to get how many cars on Sunday? I know that 60 is smaller, so I'm going to have to divide 60 into 100. Whatever I get here, I'm going to do that number into 40. In order to get how many cars? Just like we did in the previous problem. Remember, your answer has to be less than 60. If you're getting an answer over 60, it doesn't make sense. Okay? Think about, and here's another way to think if your problem is reasonable. Think about 50%. 50% is half. I'm going to have 10% less than half. Half of 60 cars is 30 cars. So my answer should be less than 30 because I'm getting 40%. So double check to make sure your numbers make sense. All right, let's look at problem number 3. Hold on. I'm looking for the work I just did. Okay, so I can read the problem again. And this is way too close. Okay. Number 3. I'm also thinking, well, I'll let you do that one. I feel like I set it up incorrectly, but I don't know. Give me your answer, and if I did something wrong, let me know. I'm double questioning, double guessing my work here. All right, let's look at number 3. According to the school survey, 12% of the students at Rockwood Junior High School speak Spanish. There are 36 students at school who speak Spanish. How many students were surveyed? So again, let's try to look for the quantities and look for the parts and the wholes. According to the school survey, 12% of the students, there's a quantity, 12%, 12 over 100 of the students, at Rockwood Junior High speak Spanish. There are 36 students at the school who speak Spanish. How many students were surveyed? So here we're trying to figure out what's the part and what's the whole. So if we look at 36 students as our quantity, those 36 students are the 12%. They're not the whole. They are the ones who speak Spanish. The question is asking, how many students were surveyed? How many students were there that answered the survey? So we're looking for our whole in this problem. So I'm going to start with our percent. 12 over 100 is 12%. They're telling us 36 students speak Spanish. How many were surveyed? So total students is our question. So for this one, what do we do to 12 to get 36? 36 is larger, so we're going to multiply by something. What multiplied by 12 gives us 36? Do the same thing to 100. Total, and we got a label, total students surveyed. All right, I'm out of room. I got to flip my page. Number 4. A tiger can eat food that weighs up to 15% of its body weight. If a tiger can eat 75 pounds of food, how much does a tiger weigh? So think about part and whole. Again, look for quantities. A tiger can eat food that weighs up to 15% of its body weight. That's a lot. If a tiger can eat 75 pounds of food, how much does a tiger weigh? So, 15% is our part of our percent proportion, 15 over 100. If the tiger can eat 75 pounds of food, that should say pounds. I'm not going to go back and fix it though. How much does the tiger weigh? So what's our part? Is the amount that it weighs the whole, or is the amount that it weighs the part? In this problem, the amount that it weighs is the whole, because the whole is the 100% of its weight. So let's set up 15 over 100. That was our percent. And if it can eat 75 pounds of food, how much does it weigh? So again, what do we do to 15 to get 75? Do the same thing to 100, and you will say the tiger weighs in pounds. Okay, 2 more problems. And these, again, are slightly easier and slightly different than the problems that I had assigned you the last 2 days. But they're still important. All right. Number 5. Miley's Music has a sale on music CDs. All music CDs are discounted 15%. Okay, so this is a sale problem. Mariana's receipt indicates that she saved $3 on her CD purchase. What is the full price of her music CD before the discount? So we know that she saved $3. That's her quantity. We know that she got 15% off. What we need to know is, what was the original price? So are we looking for the part or the whole? $3 is the part. The full price is the whole. So let's go ahead and set up our percent proportion. Oops. It was 15%. And she saved $3 out of the original price. So what do I do to 15 to get 3? Do the same thing to 100 to get a dollar amount. To find the original price. 3 is smaller than 15, so you're going to be dividing instead of multiplying. All right, last one. I bet this is so much easier when we walk through it together, right? I know some of you could do these on your own, but I'm glad we're doing them together. It makes me feel like we're at school and doing things normally, which is important during this time. All right, number 6, last problem. The interior paint color Melon Madness, which is kind of like the color of my green walls in my house, is 30% yellow. Raul uses 72 ounces of yellow paint to mix the last batch. How many ounces of Melon Madness did he make in the last batch? Okay, so look for quantities, look for parts and holes. The interior paint color Melon Madness is 30% yellow. There's our percent. He used 72 ounces of yellow paint to mix the last batch. How many ounces of Melon Madness did he make in the last batch? So is 72 a part or a whole? Remember, only 30% is yellow. So some other part has to be a different color. So yellow, the 72 ounces of yellow is a part, which is going to go on top. So we're going to look for the whole. %30 is yellow. He used 72 ounces of yellow out of the total paint in ounces. So, what do I do to 30 to get 72? I'm going to multiply by something because 30 is smaller than 72, so I'm going to figure out what that is by dividing. And then I'm going to do the same thing to 100. For this problem, I want to stress to many of you that you are going to get a decimal in this problem. Please, please, please be aware of your decimal when you do it for the bottom, because it's going to make your make a difference for your answer. If we're looking for the total amount of paint in ounces, we know it's going to be larger than 72 because 72 is a part. 72 is 30%. So 72 is not even half of the entire amount that he uses. So think about that in your answer when you're trying to make it make sense. Also, you can see in this pen cap, I told you the cat came to wreak havoc before I started this video. He ate this pen and you can see his teeth marks at the very top. I don't know if you can see that right up in here. He's so naughty. I'll show you guys a picture tomorrow. That's why it's hard for me to bring work home, because they just mess up everything, man. Okay, so write your answer. Total ounces of paint. Type your answers into the Google Doc and submit. I hope this was more helpful. I will make a video to help you go over the other problems if we need to do that. I'm trying to give you guys feedback just like we do for math tests, but sometimes that's still hard. So for those of you that need it, I can create a video. Email me. Tell me you want the video. Okay? That's it for now.